Alright, so we were given the problem a skier is being towed up by a tow rope on a slope at a constant speed, and we're supposed to draw the picture of the skier being towed up on the hill and show the forces acting on him. So we have the normal force, which is perpendicular to our slope. We have our tension force, which is coming from the rope from him coming up the hill. We have our friction, which is in between the skis and the slope of the snow. And then we have our gravity force, which is coming down. Now, each of all these forces here added up together actually equals our net force. And so we have our free body diagram of the skier on the slope being towed by the rope, and then we also drew it on an XY coordinate here, just to simplify things up in the directions.
Alright, so a key word is being pulled up the hill at a constant speed. So we know that there is no acceleration in this problem. So right away, we know that net force, or the summation of all our forces, equals m times a, and with a being 0, our net forces combined together equals 0. And how we calculate this is we split up the problem into x and y components. So over here, we have our normal force with this arrow right here that has a negative x component and a positive y component. Over here we have our tension that has a positive x component and a positive y component. And then right here we have our friction force that has a negative x component and a negative y component. And then the force of gravity is just straight down, so that is strictly a y component, no x component. And so over here we actually have the calculations of this. So for the y component, we have the force of the y component of the normal force plus the y component of the tension force minus the y component of the friction force minus the force of gravity, because once again, it is only a y component, no x. All equals 0 because our net force equals 0. So then, once we simplify it out, then the force, the y component of the normal force and the y component of the tension force added together equals the y component of the friction force plus the force of gravity. And then for our x component, we only have 3 forces acting on the x component because the force of gravity is only in the y direction. And so we have the force of tension, the x component of the force of tension, minus the x component of the friction force, minus the x component of the normal force equals 0, once again, because our net force equals 0. And so simplified out, the x component of the tension force equals the x component of the friction force plus the x component of the normal force.